everyone, in this video I'm going to revision about the time delay of RCA, which is look ahead carry adder. Look ahead carry adder. Yeah, so carry look ahead adder. Carry look ahead adder. So to understand the delay in a carry look ahead adder, we actually need to construct the carry look ahead adder circuit first. So Sam, we start with A0, B0 and C0. The A0 should use XOR with B0, and after that another XOR. So this means like A plus B, and you get either 1 or 0, and then this is your output S1. Okay, so means it's A plus A. If A XOR A, so A XOR B, if both A and B are 1, it will output 0 then. Okay, so the C0 will be connected to this S1. Okay, so this is the carry. So the carry is determine whether we want to make it 1 or 0. Okay, so we know that if ABC, we have a truth table 0 0 0, so 0 0 1, we construct the table first. Truth table 1 0 1 1 1. Okay, we know that Ci plus 1. Okay, so we want to find Ci plus 1. So how do we find the Ci plus 1? Okay, so we can divide into 3 stages. Okay, this is the last stages. Okay, so this is the 0 stages. Okay, so in this stage, we know that the Ci plus 1 is always 0 lah, no matter how the condition change. But in this case, the Ci plus 1 is actually equals to Ci, because you see when the Ci is 1, then the what is that? Okay, so we can construct the 0 zeros. So 0 1 0 1. Okay, so we know that the output is Ci plus 1, and for the last one we know that the output is always 1, so it is 1. Okay, so for this one we actually call them as carry generate, because a carry is generated. So for this one, it is what we call carry propagated. Why carry propagated? Because if this one, if we want to determine whether the future carry out is 1 or not, is either 1 or 0, we actually need to have the previous C1 value. Means the previous C1 is actually propagated to the next C1. So I hope that you got what I mean. Okay, so actually, so I can carry propagated as P. So P is actually equals to carry propagated lah. So what is carry propagated? Actually, it is A or B, right? Because if A is 1, then it is carry, it will output 1, right? So if output 1 means the P is actually dependent on Ci now, isn't it? Because if A is 1 and P is also 1, the output is actually related to Ci already, right? Okay, so this is A, Pi. Okay, so Gi is carry generated is equals to AI, Bi. So they are like AND gate AND gate lah. So now how do we draw is we want to make it connected to OR gate to generate P0 and AND gate to generate G0. Okay, so this is how we connect them lah. So A connect to A, B. Okay, so this one again A, B. Okay, so this is how we connect, and then this and then we know that the Ci plus 1 is actually equals to Pi plus Pi. Okay, so Pi is A plus B, right? So just now I said that Pi, in order the future carry is 1 or not, actually it is dependent on Pi and also the Ci, isn't it? And it is also dependent on Gi lah, because if Gi equals to 1, then the future carry should be 1, is it? Do you agree? Okay, so yeah, so if the future carry is 1, then it should be okay. Okay, so that's how we connect. And so if we want to generate the C1, we actually need to based on this equation to generate C1. So this circuit actually relies that, make it realizable that we can generate the carry all at the same time, is it? This is the special feature for carry look ahead adder, because all the carry bits are actually generated at the same time, is it? Compared to ripple carry adder. Okay, so P0, okay, so P0 is actually have an OR gate with a C0. Okay, so an AND gate, sorry. AND gate, and G is actually have an OR gate with this. Okay, so what the output is C1. Okay, the C1 will be connected to S1 lah. So the depends on you want to how many bits. So this is connected continuously. Okay, this is a continuous circuit. So this circuit actually make the how to say, actually make all the carry bits are generated at the same time interval. Okay, so because the circuit, because to generate the carry, actually the circuit only rely on the A and B, because the carry in this carry look ahead adder is actually dependent solely on the input A and B only. Yeah, so that's how this circuit works. So we can see that the critical delay path to generate S is actually 5 tau, right? Because let's say if want to generate S1, we need to connect this C1 to this S1, right? So C1 and this S1. Okay, so you see this C1 we need 1 tau, 2 tau, 3 tau to generate, and after generate the C1 we need a 2 tau delay also, so that it can generate S1, is it? Okay, so the worst case path is actually 5 tau lah. But for the carry generation, it requires 3 tau to generate the carry. Okay, so now if we go back to Ripple carry adder, so Ripple carry adder is more or less the same case, but it is also a bit different at the same time. So I will explain. I will try to explain on my best. Yeah. Okay, so this is C naught, B naught, A naught. Okay, S naught. Okay, so for this C naught, okay, so I try to do like the diagram shown in my PowerPoint. So basically like this. A, B naught, okay. So, yep. Okay, so from this diagram we can clearly observe that. So what do we observe is that to generate okay, so to generate this S naught, we need to a time delay about 1 tau, 2, this is 3 tau, I mean this is 2 tau, okay, this is 2 tau, and this another 2 tau, means this is 4 tau. But if we want to like go to the next circuit, so after that is like we need to consider quite a lot of things. Okay, so it is this. Okay, so this is how we get this C1. So it is obvious that this C1 actually Ripple carry adder is like it will ripple when the carry is propagated. So it will ripple around 2 tau. So from what you can see, where try to tap video. Okay, so from this diagram you can see that this is the example circuit of Ripple carry adder. So you can see that the 2 tau every time. So 2 tau, 4 tau, 6 tau, 8 tau, and the value will be produced at 10 tau. The last speed will be produced at 10 tau. So this is the working